All right. 87 through 92 continues on with the theme of questions of similar type to the ACT. A lot of people were like, why do you make us take these? This isn't the ACT. It's because I feel chemistry is the best class to help you prepare for the ACT because I do it in homework. When we do labs, we make observations and take our data and form conclusions. That's one of the most important and basic skills that you should get out of science class. The ACT seems it's important to see if you did end up with that skill. All right, so we'll have questions similar to this type throughout the whole year to hopefully help you do a little bit better. All right, in this is a classic type of ACT question where you're given 3 experiments. You're given brief information about the experiment and some of the data, the actual results. All right, so the first thing that you would need to do is to quickly read about experiment 1, 2, and 3. All right, there are 3 different experiments because they're going to test 3 different things. All right, in experiment 1, you can go ahead and read that. It's a strip of magnesium is ignited and allowed to burn. It burns with a bright flame, forming 16.6 grams of white powder. We had 10 to start with. All right, this powder does not dissolve in water, but it dissolves readily in dilute hydrochloric acid. Experiment 2. Again, we have 10 gram strip of magnesium. This time it's burned in a sealed gas containing only oxygen. Experiment 2, it was in air. So there's our difference. Experiment 1, burned in air. This one only in oxygen. It burns much more violently and quickly than in air. It again forms the same amount of white powder with the same properties. Experiment 3, you have a 10 gram strip of magnesium again. It's burned in a sealed flask containing a different colorless gas. All right, so what we've noticed in the 3 experiments, we're changing what the gas is in the tube. All right, this time it burns more slowly and forms 19.1 grams of gray powder. In hydrochloric acid, this powder partly dissolves, leaving 2.5 grams of a black residue. All right, so we're going to take all 3 of these, combine this information, and answer these questions. 87 says in experiment 1 and 2, so we ignore experiment 3. Why is the mass of the white powder greater than that of the magnesium ribbon? So we have to think, what on earth caused that powder to weigh more than the metal that we started with? We know that the flask was sealed, so we have to realize that the only thing we could add to it must have already been in there, and all it was in experiment 1 was the air, and experiment 2 was the oxygen. All right, if we're bright students, we realize that air has oxygen in it, but not as much. So let's look at 87. A, the flame has made it heavier. That is incorrect. Flame does not increase mass. The flame is just a flame. B, in burning, air has been driven out of the magnesium. That doesn't make sense, or it would weigh more. C, the powder combined oxygen. Okay, that one sounds good. Let's look at D. While the ribbon burned, it absorbed impurities. That can't be because in experiment 2 it said there was no impurities. Our answer has to be C. When we burn this in the air and in oxygen, oxygen reacts with the magnesium to make it heavier. All right. Each one of these steps up the difficulty a little bit more. Last 30 seconds, look at 92. When you read through 92, we want to know why experiment 3 we got something gray and when it dissolved something black. Read through those and think what you know about colors and which one of those things listed is a gas and it has black stuff in it, and I think you can get through it. All right, this is a difficult set of problems, but it's challenging in a very good way.